This is a screencast about a trickiness that came up in class. If f of x equals 1 over x, we're supposed to prove that f prime of c equals negative 1 over c squared for all non-zero c. And we worked out the proof, and the easy part was let epsilon be bigger than 0. We're going to pick a delta, which we'll pick later. Then for all x such that this is true, you do the standard derivative setup. And then we end up with x minus c over absolute value of x times absolute value of c squared. And this is where a lot of people got stuck, and naturally so. So I want to walk you through kind of how you take care of this x down here. This x is the big problem that is prompting the screencast. And so the strategy, which is a very, very common strategy, is that I don't know how to deal with this thing, so I'm going to find something bigger than it and deal with that instead and make it less than epsilon. In particular, I'm going to replace this absolute value of x with something smaller than it. And if I replace the denominator with something smaller, then that makes the whole fraction bigger, and then I'll prove that that bigger thing is less than epsilon. This is a huge idea for real analysis, so make sure that you have that down before you proceed. Okay, so here's what we're going to do. Over here, I know that I get to pick delta. I haven't picked it yet, such that x minus c is less than delta, where delta is positive. Well, what does that mean? If you unravel this, this means that negative delta is less than or equal to x minus c, which is less than delta. In other words, x is between c minus delta and c plus delta. So this is great because this gives us an idea of how to find something smaller, right? I told you that the strategy is we're going to replace this absolute value of x with something smaller than it, so c minus delta, and then I get something bigger, and I'll prove that that bigger thing here is less than epsilon. The problem is delta is undefined. Basically, what I'm doing right now is I'm trying to work out what I should define delta to be, so I can't just use this because my delta hasn't been defined. That'd be a circular definition. I define delta in terms of delta, which is wrong on so many levels. But here's the idea. I'm going to use the fact that I haven't picked delta yet and that I get to pick delta to help me out. So here's what's going to happen. So one common solution is if here's c, you might make sure that the picture looks something like this, c plus 1, and then I'm going to make sure that my delta is going to be somewhere in here. So that's a common situation. We're going to do something like this, except I'm not going to do, we often pick 1, it could be any constant. I'm not going to pick 1, that's supposed to be 1, it kind of looks like a 2, because if c equals, say, 1, then c minus 1 is a problem when we divide by it. So in other words, if I pick c minus 1 to be kind of my lower bound, if I guarantee, if I write myself a post-it note so I guarantee that c minus delta is going to be within c minus 1, I could replace it with c minus 1, but then I'd have c minus 1 equals 0, and I'd be dividing by 0, which is no good. So instead, I'm going to, let's temporarily assume that c is positive. I'll handle c negative very soon. Instead, I'm going to try to make sure that that my c minus delta is between c and c over 2. And I can do that pretty easily, right? So, right, notice that c minus c over 2 equals c over 2. So I'm going to make delta less than or equal to c over 2 if c is positive. So I'm going to stop here, and I'm going to continue with the second part of the screencast. So await part 2.